Hi everybody, it's Amy here. This is the very end of week number 3. I know you guys have been working on your skin and tissues chapters. I've gotten all of your information in. I got your Test Your Knowledge quiz information in with your muddiest point question. And one thing that I noticed particularly was that this week, more than the others, your muddiest points were kind of all over the board. There were all kinds of different small questions that people had. There wasn't as much of an overarching theme with everybody that had a lot of trouble with one particular topic. So because of that, I'm going to have to pick a couple of things that I did hear multiple people ask about. And if there's still something that you want some help with related to what's still a muddiest point for you, would you please put that on the Chapter 3 discussion board so that we can begin to address those specific questions if you really need some help with those before we move on. Please try to do that today or tomorrow. I'll be checking that board, and I know other students will be checking that board as well. Let me get started really quick with my information. I'm going to pause this real fast and come back in just 1 second. Alright, sorry about that. My phone started ringing in the background and I had to get that to stop. So I want to go ahead and jump into talking about some of the different accessory structures in the skin that are actually involved in thermoregulation. That's a particular physiological topic that is really a great example of how our body deals with homeostasis and how we utilize the help of different types of organs within a system to bring about that balance. So in this picture, I'm going to show you a couple of things. When we talked about homeostasis earlier, do you remember that we discussed when we're dealing with negative feedback in particular, that the effector would usually be a muscle or a gland. And we're going to see that as we go through these examples here today. So if we're having issues with body temperature, there are going to be different muscles or glands that get activated as particular effectors by our brain. So let's talk about some of those. One is here, the erector pili muscle. I know you guys have looked at that, and you probably are aware that this erector pili muscle is attached to the base of the hair follicle. And so when that muscle contracts, it makes the hair stand up. And it goes straight up. And that's what gives us goosebumps. The interesting thing with us is that there's not a major insulating factor to this hair standing up like there would be for other animals. But this will help you get the idea though. If you think about this skin being on a furry animal like a bear or a big cat, something like that, what happens is that as the hair stands on end, you end up trapping a layer of air right here next to the skin. And because of all of the heat that's in the skin, because of all the blood that's flowing through, the heat ends up moving up and warming this small layer of air right next to the skin surface. If the hair is all laying down flat, then you don't get that insulating space. But when you have the hair standing up on end, it allows you to have that nice insulating of warm air next to the body. One great example of this would be if you spend a lot of time outdoors. I know that when you're out hiking and things like that, there's always this discussion about having a layer that allows for insulation, maybe like a thin layer of down, and then maybe you have another jacket on top of that, because that thin layer of down in that type of a jacket is going to allow you to keep that air warmed up next to the body, and then you have that windbreaker or something that's a little bit thicker on the outside. And that's really what those muscles are doing for the skin as well. Sweat, here with the eccrine sweat gland, is another example. I'm going to jump to this slide. You can see that the sweat gland has a nerve fiber attached. This is a part of the nervous system, and so when the brain decides that the body has gotten too hot, then it's going to trigger an action potential or an electrical stimulus down this nerve fiber, and it's going to tell all of these gland cells to start secreting sweat. And as they do, it moves out into the duct, onto the skin surface, and what happens there? Well, that's where this water gets converted to a gas. So when the sweat evaporates off of our skin, we're actually taking heat from inside the body and using it to convert the water into the gas. just like when you boil water, right? You start with a pot of water. There's water in here. You have the flame underneath it. What happens? The pot starts to steam, right? You get all the steam coming up, and if you let that pot of water sit on the eye too long, then that level of water goes from here all the way down because you've lost all the water, and you've done that through the input of heat from the stove. Well, when we evaporate sweat, we're doing that through the input of heat from our body, and the process removes heat because we have to take this heat, use it to convert the water to the gas, and so the heat, the amount of heat in the body drops down because we're using that heat to evaporate the sweat. So that's a good thing to understand as well. I also wanted to point out, remember this discussion about the veins and the arteries, particularly the arteries in the dermis, are going to be involved in maintaining heat or increasing heat loss. And we do this through vasodilation or vasoconstriction. So to dilate a vessel means that you go from this diameter to this diameter, which means that there is low blood flow, and now there is increased blood flow. And if this vessel here in the skin increases blood flow through it, that means that there is more blood, which is warm. So more heat is coming to the surface of the skin that can get used and can get lost into that external environment. Let me back up. When that happens, that's when the face ends up looking flushed because we brought the blood to the skin surface. So maybe when we are exercising, our body's gotten too hot, so body temperature has gone up too high above set point. So we dilate the blood vessels in the skin, we bring more blood to the surface, that makes us look flushed, but it also allows us to begin to transfer heat out of those blood vessels and into this external environment. I'm going to erase this and start back over with what happens when our body gets cold. Same kind of thing. When our body is getting too cold, we actually need to keep the heat. We need to retain the heat deeper in the body, close to those really important organs like our heart and our lungs. We need to keep it all in the core. We don't want it to escape. So to do that, we take our blood vessel that maybe was this size and we shrink it down to that size. So we have decreased blood flow to the skin surface, and because of that, we reduce heat loss because you are, because you are removing blood from the skin surface, so there's not as much blood that can lose its heat across the skin. And because of that, you end up retaining or keeping the heat down deep in the body. So when that happens, what's the effect in terms of what somebody's appearance is? Well, that would be pallor or just looking pale because you're pulling all of that nice red color in the blood away from the skin surface. What's the protein, the pigment that's in the blood that makes us look pink? Well, remember, that is hemoglobin. So because we pull the blood away from the skin, that means there's less hemoglobin near the surface of the skin. And so if somebody was fair, had a fair complexion, say like I do, it would go from having kind of a pinkish color to looking really, really white, because all of the color would be pulled out of the skin surface. Just as a side note about that, remember that if you have a lot of melanin in the skin, melanin is really going to take priority in terms of color, so you're not going to notice this issue of pallor as much in somebody that has a higher concentration of melanin in their skin. This process can go to such an extreme that if you end up having blood that is poorly oxygenated, where you actually don't have as much oxygen-containing hemoglobin in the body, you have deoxygenated hemoglobin, then you're going to end up creating more of a blue color to the skin, because hemoglobin that doesn't have oxygen bound has more of a bluish purple color. So if you have fair skin, then you would see that blue color to the skin. If you have a lot of melanin in the skin, there are a few places where you will see this blue color. That tends to be in the nail beds, also in the gums or on the inner surface of the lips. Those are places where you can still look to notice that cyanotic appearance, because those areas don't have as much melanin as the rest of the skin does. So this is just some information about how our body utilizes different muscles and glands to help us maintain homeostasis. Excuse me. Really quick before I go, I want to point out one thing. When we talk about vasoconstriction and vasodilation, what we're dealing with is a layer of smooth muscle that's on the outside or in the wall of these blood vessels. So you can contract that smooth muscle and that constricts the vessel. Or you can relax that muscle and that dilates the vessel. Okay, so that's really, those effectors are actually muscles. They're smooth muscles in the wall of those blood vessels. So if you have more questions, again, like I said, please post those onto the the week 3 discussion board. I want to make sure that if you really need some help that you're going to get that. So please let me know through that. You may have been just trying to make sure you came up with something for the muddiest point. So I really want to make sure that if you need help, you let me know. So give me some feedback if you need some assistance, and I will be here today and tomorrow to help you with that. Thanks a lot. Bye.